morning, my dear students. And today we are going to be discussing about the basic concepts of vibrations. As you know that if you take any kind of the body, when we are applying some kind of force on that system, then it will start to vibrate and it will create a sound also. So right there, in the engineering sectors, the engineering materials are mostly prone to go get the vibrations. So how these vibrations are generated and what is the main cause for that, what is the physics behind of that vibrations, today we are going to be discussing about it. And here we can see, so as we know that every body has its mass and elasticity, right? And we can take it here, the mass is the inherent property of the system and elasticity is the main cause for the relative motion. For example, I have taken here the different types of the solid objects with the different shapes. If these are going to be, as we know that engineering materials most of the time they have the elasticity in nature. So then what will happen here? The mass is the inherent property of the system and it is completely packed with the matter and it next, elasticity is the cause for the relative motion. How it is going to be cause for the relative motion? As we know that within the proportional limit of that particular body, that body is trying to regain its original shape and the size when we are removing the load. So these are the main reasons for the mass and elasticity, which are the inherent properties of the system. So for this one, I am going to bring one example is the simple pendulum. This is the well-known example, right? And here I am going to be taking a string and the mass was attached here. I am going to be considering this is the main position of the system. As we know, in the main position of the system, the tension in the string is going to be moving upward direction, the weight of the ball is going to be moving in the downward direction, right? So then the system is in the equilibrium position. Now what I am going to do, to understand the basic concepts of the vibrations, then I am going to use some external excitation. So when I am doing the external excitation, so then what will happen, that I am going to show here, the external excitation I have given to this mass. Then this mass position is going to be reached to the another position. That position I am going to be called exciting position. Why I am going to say exciting position? When we are disturbing from the mean position or equilibrium position, it will reach to the next position. Then what happened? Some internal forces are going to be generating within the system. So those internal forces are going to be maybe stored in terms of elastic energy or the strain energy. These are the main cause to bring back this position, exciting position to the mean position. When we are moving, this is going to be internal forces. That means that body here is going to be developing by itself because of the elastic in nature. So the strain energy, when you are going to be, the material is going to be strained, then it will store that energy within the proportional limit. When the proportional limit will cross, then it will reach to the plastic stretch. So then it will never get back to its original position. So then what will happen here? The elastic energy is the cause to bring back to the equilibrium position, that what we have discussed. Now after the initial excitation, so that position is going to be reached to here. So that means, so here that energy is stored in terms of strain energy or elastic energy. Once I am going to be removing this external excitation to the system. So I am going to be remove the external excitation from that. Then what will happen here? So I remove the external excitation. So then the stored energy in the strain energy, that's converted into kinetic energy. That object is going to be trying to back its original position. That is with the help of the kinetic energy. But when it comes to reach the main position, right? So when it reaches to the main position, because of the inertia forces, that object is going to be reached to the next position, next exciting position. So the kinetic energy here also it will reach to the next exciting position, and then this energy is going to be converted into the strain energy, right? And the strain energy again after the certain time, so then what happened? This strain energy is going to be relieving from the system and it is moving back to its another exciting position. So then what happened here? The strain energy is converting into the kinetic energy and kinetic energy is going to be converting into the strain energy. So in this way, the motion of a particle repeat indefinitely until the kinetic energy and the strain energy is going to die within the system. Then we can say that there is no vibrations. So from this explanation, we can do the definition for this one is any motion which repeats itself after an interval of time is called vibration. I am repeating again here. Any motion which repeats itself after an interval of time is called the vibrations. The same definition we can say in other terms, the motion of a particle is to and fro from its mean position is repeatedly repeated. So with the help of this simple pendulum, we try to understand the definition, what is the physics behind this vibration. For the extension, I am going to give the example 2 here, that I am going to be taking the solid body. Right? In the solid body, what happened? One side I was fixed here, another side external excitation I have given towards the axial direction. So then what will happen? This solid dot is going to be there. So that is the mean position of the system. Once we apply the load, then what will happen? This total object is going to be trying to compress within the certain limit. That is up to the proportional limit. It means that has stored the strain energy. Once you remove this external excitation, then object is going to be trying to move in the opposite direction. So then the position 1 to 2 and 3 it will going to be reached. Then again elongation is going to be taken. Then strain energy is stored and then it's going to be back. So that means that object is started to move and to and fro from its main position, and that motion is going to be repeated. So that is going to be the one example from this one. The next one, example 3, we can take it here, the water. That's the wave formation is going to be there. That's we can see very nicely when when we are going to be throwing a stone inside the water. So then what happened? The wave formation is going to be there. That means the atoms are going to be started to vibrate. That we can see very clearly. And another example is going to be the air. So this is also the best example. While we are talking, the people are listening because the atoms are going to be vibrating within the traveling of the time. So these are any medium in the universe can vibrate because of the external excitation. I hope from this one we understand what is the physics behind the vibrations and what is the main cause for the vibrations. The internally we do have mass and elasticity, right? And then we do need to give the external excitation to the system. Once you give the external excitation, and internal forces are going to be developed in terms of elastic and strain energy. And this is going to be the main cause for the generating the vibrations of the system. Thank you.